Next up, we will be joined by Bryan from Google with a session that's as witty as it's insightful.
Titled Error 404 Genius Not Found Yet, Mark takes us behind the scenes of AI innovation, where every failure is steps forward brilliance. Let's give a warm welcome, Bryan.
Okay, cool. Hey, good morning. It's a pleasure to be here. This is me, and we're going to have a little bit of a walkthrough. Very similar, actually. A lot less mathematics, but same topic and same philosophy. And it's really nice to see some of the homages to Google and your brother's work at Google as well in your presentation. That was super nice. So, myself, Bryan. Yeah, I'm a senior cloud engineer at Google Cloud. And we're working with AI a lot in the industry right now, and we're working with everyone. Actually, I've come from Finland, so I haven't come from the headquarters of Nokia itself. I've had the pleasure of working with Nokia for the last 15 plus years, and I've been 6 years at Google now as well. So it's been a very interesting journey, and it's very interesting to see where we are now with AI. So let me take you through a little bit of a different perspective, but with very similar concepts and topics. And a lot of the questions that came in the room I think are also super relevant. So this is what Google's CEO is saying about AI, right? Essentially, and I think a lot of us are perceiving this as well, is that it is one of the most profound technologies we are working on as Google. In fact, Google is now 27 years old. And we've literally been working on machine learning for 27 years. Because the Google search algorithm is exactly what the last presenter was talking about. It's a function with inputs and outputs. And the Google inventors were working on this. And LLMs, AI, and chat, since 2017, Transformer, one of the largest things in the industry to transform how we perceive AI. Most people only perceive AI with the invention of ChatGPT. In fact, the technology was out there way, way longer than ChatGPT, but it's more being commercialized. And sometimes Google was perceived as being a bit late. So that we see it as more important than fire and electricity, right? It's almost like the evolution from fire to electricity and the journey we've gone on. So the potential is huge, and that's how we view it. Now, the AI opportunity itself is more like on the commercial sense these days, that we as companies, as humans, we thrive for efficiency. We want to improve our productivity. If we are going to create a mathematical formula, we want it to be the most simple formula, like E equals mc squared, rather than a very long one, right? We look for simplicity, and we want to increase productivity. In enterprises and businesses, we want to do that because everyone here wants to make money and wants to get paid. But the most important one for me and for Google and its core is innovate faster. So how do we innovate faster? So we'll address the first two, because I think we're all in an enterprise scenario here. When we talk about the introduction of AI, this is the expectation we see. I think everyone in the room has been told you need to adopt AI because it should have reduced costs over time. I'm sure there's probably, if I asked you to show your hands, almost everyone would raise here. And then the second one for AI in kind of the enterprise sense is that, well, the revenue should go up as well, right? And actually, this is actually a very basic mathematical function of how economics works. So if you look at what's happening in the European Union, I'm coming from Finland. Finland's growth rate is actually last year, or predict what it concludes even this year, will be about 0.8 to 1% growth. So we're a little bit stagnating with innovation, GDP, and output. And this is kind of how we see that everyone's looking to AI to accelerate this, to make us more productive, to make society more productive, right? And I think it can do that. But there's also a lot of expectations around AI. So how do we understand how to apply AI in what categories? And to do this, you really need a framework. So this is what we do internally at Google. We don't immediately jump to the top right and say, how do we completely transform our way of life? Transforming a way of life takes time. But there's a perception with AI and LLMs that you will just immediately transform your complete way of working. In fact, the reality is you will typically spend more time initially, where we are now today, in the accelerate quadrant. So we'll just look at tiny ways to optimize. I don't know if anyone's heard of the rule of 1%, where you just optimize by 1% and 1% more and 1% more. And you do that over time, and effectively, you're compounding your increases. That's accelerate. Evolve is where you say, and it goes back to the human in the loop question, you say, well, what if we fundamentally change the way we do a process? So first two steps of the function or the process, human. Second two steps, AI. Yeah, this will transform the way the process is. The second two steps will be inherently probably more efficient, done in less time than the first two steps, right? That would be like evolution. And incubation is kind of, again, on the far bottom right. We don't know what the impact will be. That goes back to questions like AGI and other things we haven't even thought of yet. But we will experiment with. And it's really important to experiment with AI. We see a lot of resistance to experimentation with AI because, well, I don't know if it can do this, or I don't know if it can do that. Well, have you tried? And quite often, I spend most of my time when I'm talking to people out there saying, hey, have you tried? And after, no, I've not tried. That's incubation. So it's really important to fail. At Google, we fail a lot, actually. So we're almost famous for creating products and killing them. Yeah, there's a few people laughed immediately in the room, right? Like, we even have a web page dedicated to it because we like to incubate and we like to fail. And we know, even inside of Google, the faster you fail, the faster you learn, and the faster you grow. And so incubate is one of the key things. But I'm going to focus a little bit on evolutional and transformational. So if, again, like, nice image here generated for us. If we go from fire to an oil lamp, and we go to oil lamp to candle, and candle to lantern, they're kind of increments of each other, right? When we went from lantern to light bulb, that was a leap, right? Like, that was a big leap. And then you could even say that, like, well, how do you improve with electricity? Well, then we got cathode ray. And then LEDs, well, LEDs have completely transformed the lighting industry altogether, right? So, like, we're going to look at this part of it. And this is not me sucking up to Nokia, by the way, but I thought it was important to kind of take a little look at this. So if you look at, and I've done something really, it's going to annoy certain people for detail here, the chronology is not correct. And I'll explain why in a minute. So if we look at one of the most important ones here, right, the transistor. We wouldn't even be, like, this laptop would not exist. The cameras would not exist. Everything in this room would probably not exist, including the lighting and the projectors, if Nokia Bell Labs hadn't invented the transistor, right? Really good example of innovation. And the reason I have this slide, we'll come back to it later on, is that I want to showcase that, like, how AI and certain failures are helping us accelerate learning as well. But it takes time. As you can see, there's some gaps in kind of the innovations here in physics and chemistry, cathode ray, like quantum dots, thank God for that. TVs are much better with quantum dots, so thank you, Nokia, again, for this. And then background radiation. I mean, you guys aren't slacking here at Nokia, right? Like, so this is an important caveat, and the previous presenter covered some of this, and I'm going to be less technical about it. And I think this question comes up. I heard it in the speaker room while I was, sat there just preparing for the session. And let's look at, like, the human brain. But this is not going to be an apples to apples comparison because the technology and the framework and the benchmark for the biological brain are not the same as they are for the artificial brain. So let's start with looking at the benchmark first, right? And this might go to some of the questions that came in the room earlier. You almost took my thunder as well, by the way, for this, but this is good. So processing units, neurons, right? The ability for the human brain to fundamentally process information, and we have about 86 billion of those. That's how we kind of compute. That's kind of our compute power. Now, connections, so synapses, they're the points between neurons, and they're forming those kind of, like those artificial networks, the connections between data. That's how we associate things. We build more and more connections, and we lead to kind of an understanding, and it builds that complex network within inside of us. Now, where are we on the human scale? We're about 100 trillion trillion connections. So, okay, it's a trillion, that's a big number, it's more than a billion. And that's our complete web of complexity. And the most interesting thing about that is that actually the number is anywhere between 100 and 500 trillion. But don't worry, you're all about 100. You're not any of you are smarter. You were smarter when you were younger. So when we're born, we actually have more synapses. Until we're about 5, 8 years old, we go up to like 500, maybe even a bit more, because we're sponges when we're young. And this goes to learning, right? We're absorbing the world around us. Like we're touching everything. We're putting stuff in our mouths we shouldn't be doing. Like you've got small children, you know that one. We're trying to understand. We're learning the world around us through experimentation, right? So let's have a look at the alternative then. So what are we comparing against? So when we talk about large language models, which is essentially everything that's powering Google Gemini, ChatGPT, Claude. Yes, I'm Google. I'm happy to talk about other models other than our own. It's fine. So we see LLMs as our digital counterpart because we're interacting with this technology through the one programming language we're all very good at. Some of us are better than others. It's conversation. This transformed how we interacted with AI. Before, it was literally machine learning models, advanced mathematics, but now you can ask stupid questions. I really like the example of asking for a prayer or a sermon. Now you can interact with artificial intelligence in a way using the programming language that everyone understands, and that is the ability to speak and write. I had a bit of trouble with that, even if I'm an English speaker sometimes. So now, when we look at LLMs, and disclosure here, I don't know the exact number in Google's numbers, and we get some estimates, but like, if anyone's been on Hugging Face or done any experimentation with models and downloading them even to their laptops, you can do that these days, right? Like, before language models were kind of seen as something that you needed like vast compute resources to run. You can run language models on Raspberry Pis, on Edge, on cameras. Like the models have compacted in size a lot. But let's look at some of the bigger ones. So when we look at large models, it's 100 billion to 400 billion. Now remember, we were talking trillions. So we're still down in the billions here. So when we kind of get the benchmark, right? The largest estimates is up to 1.8 trillion. Maybe more, maybe slightly less. So, okay, we're getting there, right? Like, you know, that's a lot of connections, a lot of parameters, a lot of associations, a lot of learned knowledge there. But it's still only 1.8 trillion. And so I'm going to talk about why we kind of are perceiving this. So let's go back and just remember the human brain, 100 to 500, depends on the age. Actually, as you get older, you might lose a few million if you enjoy the Hungarian wine locally here. But don't worry, it's just a few million. You have trillions. You'll be fine. And actually, synapses can reform after a while, so you can get those few million back as well. Don't worry about that. So this means that if we use this very loose and very inaccurate association between the brain has 55 to potentially 270 times more synapses than the largest models that we have to date. Okay, that's interesting. We're going to come back to this topic in a minute, but we're going to kind of pivot and just flip even my own presentation upside down. Right? So, Adrian said I should do a sales pitch. No, that's fine. So, I want to talk about one of Google's models that is not Gemini. It's the open one we have called Gemma. It's one you can download. It's one you can experiment with. And the reason I bring it up is that, well, one, you can all access it and play with it. But two, it does something very interesting. It kind of flips this perception of like, it needs to be more intelligent, it needs to have more parameters, completely on its head. And I'll show you why. So this is the first time I've ever done this LM Arena, actually in my slide deck. Every time I see someone from Google show up, I'm always, benchmarking, I hate benchmarking. But I'm doing it now. So there is a benchmark out there for the perception of how good an AI model is. And it takes different parameters. It takes human upvotes based on the responses it can give to certain problems, or whether it's a coding example, whether it's a language example, maybe it's an image example. And most of these models are multimodal. And surprisingly, this is for Gemma on 27 billion, is actually rated up the top. And you think on the far left, we have 671 billion. Yet a 27 billion model gets a better rating than a 670 billion model. Shouldn't that thing be more intelligent? Why are we as humans saying, hey, the 27 billion model is actually giving way better responses than, or very close responses to the 670 billion? This is kind of, this is again interesting. And then the other thing here is that when we look at these models, and there's a lot of concern out there, is that what resources will we need to run these models? The more and more parameters, the more and more compute. Google was very famous for developing its own chips to run AI models. So we call them TPUs. There's a lot of GPUs. Nokia working very closely with NVIDIA, so is Google. GPUs are the more common one. We have specific chips that we invent at Google to run AI models, to go to the scale to build these very complex ones. But we don't actually need that, because when we look at Gemma, for example, and we look at the output that it can give and the ratings that it gives, Gemma runs on one GPU. That's kind of important. The far left model, the DeepSeek R1, you're going to need a lot more than one GPU. Let's put it that way. Maybe tens of GPUs just to run that model to get a very similar result about what can run on one. The reason I highlight this is because, again, as humans, we focus on efficiency, and we look for running things in the most efficient way to give the best output with the minimal input, right? And we even see this in the models. Models don't necessarily need to grow in order to give better outputs. The other reason, if we're benchmarking against the human brain, sometimes I think I'm not running fully on 20 watts, by the way. So I've been traveling the last few days. I think I'm about 11 watts at the moment, so let's see. Yeah, brain is 20 watts, a GPU, a couple of hundred. So I want a single GPU. You don't need a very powerful GPU to run Gemma. You can run them even on the standard NVIDIA RTXs. Some smaller models will even run on Raspberry Pis, but not to that scale of 27 billion parameters. Memory is actually the biggest problem with models, right? Like remembering stuff. So yeah, brain is pretty efficient. Some of us more than others. So I'm always a bit cautious using the word stupid in the presentation, but it came up a few times in the previous one too. There's this perception that AI is not able to do what I can do as a human, right? Like we're all feeling very challenged and threatened by AI. Like it can't do what I can do. And I meet a lot of customers and I have a lot of workshops where like, well, it will never be. I've told the management, it can't do what I can do. Okay, fine. Like there are some fundamental difference about like, why is the case, right? Like it doesn't have what we call common sense. I would argue some of us in the room also don't have common sense. I've met these people. I am one of them. I lack it. AI has no causal reasoning. It's very good at seeing patterns, but it doesn't understand causation. It can't explain why something happens. It can see patterns. Now, some of the more models actually, if you say that, like, what's that over there, we'll say it's a chair or it's an apple. It doesn't understand why it's a chair. It just knows it's a chair. It doesn't understand why it's an apple. There are models and experimentations where people are asking it to explain the fundamental world of physics, and it's coming up with completely new formulas, and some are correct and some are not, where it tries to understand. But essentially, the basic LLM models is more about correlation, not causation. And then again, the language itself, right? Language is super complex. I famously only speak one, even after living in Finland for 20 years. I tried French once, not very good at that either. Syntax, not semantics. It's a master of language patterns, but it has zero grasp of the actual meaning. Again, it can know what it should say, it can predict what it should say, but it doesn't understand why it's saying it. It doesn't have that ability yet, right? Now, let's go through like an interesting example, and it will tie back to why failure and it's not there. If we look at why AI is helping us, even if we think it's essentially stupid, which maybe it's not, maybe it is. AlphaFold is something Google was working on, and we actually have two mathematicians who decided they wanted to to solve this kind of protein folding problem. And what they've discovered is that, what they would have been able to do in like years, with AI, they can do in months, maybe even a weekend. I see the PowerPoint formatting here has gone a bit awry. This is a very interesting example, again, of like when we apply AI to a very specific area, right? So when we look at solving a very specific problem, processing large data sets, predicting, correlation, maybe this would be a good protein to solve for this. The purpose of this is to obviously find discoveries for new drugs, for new cures, to new medicines. And this is going to lead us on to one of the powerful parts of why AI. As a human, we have very limited capacity. If I was to give you a sequence of numbers, some of you are probably really good at remembering up to more than the mathematician in the room. Maybe you could do 10 numbers, 15 numbers. If you're like me, you'll remember 3. Famously, in all my presentations, I typically have 3 points. I borrowed that from Steve Jobs, by the way. I think he had the same problem I did. If you have 4 points, people won't remember either the first one, the second one, or the third one. But it's kind of, we're like goldfish in a sense. With AI, it's essentially relentless. It doesn't tire. It almost has infinite memory, right? Another really interesting thing in the same domain is that, like, when we think about complicated problems, and here we have, Gemma essentially looking at solving potential new cancer therapy, right? And again, that was done on a 27 billion parameter. I mean, surely we need something more intelligent than humans to look for cures to cancer. But it turns out when we put a specific topic on a specific training in a specific domain with a specific model, and even the model that has less synapses, less parameters, we're able to actually make very interesting discoveries and accelerate our understanding and learning. Another very interesting one is actually our own model, so Google's own Gemini 2.5, and the numbers keep incrementing. I was talking to, I was hosting a workshop, and there was a team of quality assurance people, and they do testing for games, actually. And so we've told the management, AI can't do what I do. Because essentially what they have to do is they have to click a user interface, they have to test a game, make sure it's working. And this is actually, I think this came out on the 7th of October, is that now we have a model that does exactly that. It takes an input, so it takes a screenshot of the screen, and it can understand, I need to click the mouse here and do this, and it can explore. And so now we actually have, well, I'm not going to use the word agents in this presentation. Now we have agents powered by Gemini that can actually interact with graphical user interfaces. And before, people thought that wasn't possible. But now we have models and APIs that allow us to use, AI can actually use a computer. It's evolving, right? Now it can use a computer. As the presenter at the beginning, like, now maybe I can give this to my parents, my wife, and my children, and then it can explain to them how to use the computer instead, right? So it's getting there. So what is our kind of aha moment from all of this, right? Like, so again, I'm seeing a lot, like, there's a lot of expectation, a lot of ask for AI to be human, and then calling it stupid when it can't do, it can't do what I told it to do. Well, it's not human, right? Like, it's not quite like there yet, and maybe it won't ever be there. But it's the very stupidity and the lack of human bias, ego, and distraction is precisely what makes AI so powerful for us, right? It doesn't get tired. You give it a problem. I really love the deep research features in AI models, where you say, go research a specific topic, and it will come back to you in a while, and it will look at hundreds and hundreds and hundreds of sources across the internet and compose like a thesis about, like, you asked me to go look at the future of, metals. What would be the next metal for the industry? Something better than steel. Well, I've looked around. I've gone and looked at 500 websites. I don't have that type of capacity to go and research 500 websites. Or I do, but it would take me a very long time. It would take me weeks, maybe even months. And then to compose a background or initial thesis on what would be the future alloy to replace steel, I would get very tired. But it doesn't get tired. It's going to come back to me in 30 minutes. I still have to validate and verify that information, right? Like, so, but this is exactly what makes it so powerful. So the other thing is that I even touched on this, right? The human brain, it's small. Some of us have slightly larger ones, but generally pretty small. It's also infinite. You know, we're not getting those pop-ups saying you need to add a storage plan to your brain, right? It's kind of, you have space, it's what you choose to do with it. We can create new synapses, we can learn new things. On the flip side of AI, it's gigantic, but it's empty. It uses context to understand, right? Like it has a very short ability to memorize stuff. So people talk about context windows, so how much information can I give as my initial input? Maybe it's 100,000 characters, maybe it's 200,000, what they call tokens. Some of the larger models, and some of the Google ones, up to 1 million, even 2 million now. So you can put entire books, code bases into these models. So yeah, like it has a photographic memory, whereas we don't. Some of us do, very few of us. And it can hold it temporarily. It doesn't store it long term. Because it has what it's already learned, but it's trying to solve a problem that you give it. So this is also a critical difference in the two. So how do we look at this? Like, is AI our stupid savior, right? Like, are we asking too much of it? Like, the reason that AI is probably, you know, at the beginning of the presentation, we talk about the transformation from, like, you know, fire and electricity. It's precisely because it's not human. I think we need to change our expectations, right? Like, it's not human. It's not going to, it will solve problems we can't, not by, like, outthinking us at the moment, but by outcalculating us. Because it's tireless. It's logical, it looks for patterns. It's going to outcalculate us. It's not necessarily going to outthink us. Maybe, not yet. We don't need it to be like a replacement for us necessarily right now, but we need it to be a good partner for us, right? And that's what we're using it for, right? And I'll go on to a few examples. You know, it's not necessarily a better us, it's a more powerful it. Now, I started with Nokia Bell Labs. I'll flip now to some of Google's, you know, Nobel Prizes as well. So one of the most recent ones is that we had Demis. You know, he is not a chemist, yet he won the Nobel Prize in chemistry. There's hope for us, right? Like, you know, that dream. You're like, I really wished I could have been a chemist, but like, you know, you don't need to be winning Nobel Prizes. In fact, many of the Googlers here on this list are not having a qualification in the field which they got the Nobel Prize in. And actually, most of ours are more recent, and AI is being used to assist and accelerate understandings and discoveries in these fields. So Demis was for the AlphaFold, for the protein folding. And I think it just goes to show that when we look at how we can accelerate learning, we have the powerful assistant for us that can allow us to win the Nobel Prize in chemistry, physics, and others without necessarily needing to be a physicist or a chemist. It might help, but for Demis it didn't help, so he got it. So I think I'm going to conclude with that it's not like, you know, the question is not will AI get smarter than us, can we get wiser with it? And that's how I see it at the moment in the industry. It's like, you know, how can we get wiser with it? How can we push ourselves to incubate, transform, experiment with AI, and just push the boundaries with it? And yeah, maybe it can't do everything that we can do, but maybe that's the wrong mindset to have. Right now, it's here to assist us and accelerate us. We might be a bit off from before it replaces us. So I think it's more like less resistance. It's not going to come in and replace you. It's going to come in here and make us a bit wiser. So yeah, that was the end of my presentation, just on time. Yeah, thank you.
Thank you very much. Thank you very much. And we still have time. So it's time for questions. Any questions here?
It's been bugging me. You said that even large language models like 1.8 trillions, like still 1,000 less wiser than humans. And we also talked about AGI is far away. But what if actually these models or the AIs are built like societies, like humans? They interwork and specialized. Would that actually get us closer to AGI?
I think the honest answer is we actually currently don't know. Like, this is the first time in human history that we can't predict even further than a year in terms of what, revolutions and transformations will happen due to the acceleration that AI is providing with us. So yes, maybe is the classic answer here, but we don't know right now, and it's very hard for anyone in the industry to say. Of course, Google, others, OpenAI are working towards this concept, right? But nobody knows what the threshold is.
Mm-hmm.
Do we get to the 100 trillion parameter model, and that's it? Like, all of a sudden it's like the light bulb moment? Or are we going to continue as we are, focusing, and have that responsibility? Maybe we use smaller models on specific tasks and problems, and that's the way the society is going. So, good question, no good answer, I'm afraid.
Nobody knows, right? Yeah.
Like,
But there are experiments around that.
everyone is experimenting, right? Like, I think even in the previous presentation, like creating an artificial environment, like even from Tesla, right? Do you know how they trained the cars to drive? They created a virtual world and let the cars drive millions and billions of miles in those cars to create the model that allows the car to drive, because they can't put a car on the road, quite rightly, to go learn to drive in downtown Budapest. That'd be interesting, right? Like, I've seen how fast you guys drive, so.
Okay, thank you.
Any other questions in the room? Yeah.
Thank you for the presentation. I like the concept that AI, in your view at least, is a tool more than a replacement for humans. But the question is for Google and big AI actors, basically. Why are these entities obsessed with AGI and ASI if AGI is not the goal and if AI is just a tool?
Why are we obsessed with it?
Yes, I mean, AGI and ASI is every time in each and every presentation for any of these big actors.
I think when you look at, I think it comes from human nature and imagination. Because one of my favorite categories is science fiction. And if you look at all of the science fiction novels, and I really love Isaac Asimov as well, right? Like, and we know he has his 3 laws. We see spaceships, we see travel to distant worlds, we see in the latest science fiction movies, there is this artificial intelligence that's just generally aware and running ship operations. Like, one of my all-time favorites, 2001: A Space Odyssey, maybe more of an odage to what should not happen in AI, like how should it always open the pod bay doors, right? Like, so I think it's just the human imagination or aspiration to build something better, more efficient than maybe even ourselves. I don't know if it's an obsession, but I think it's a human passion to strive, like as we strive for the stars, right? Like, so we're just looking to improve from fire to electricity to the next thing. Maybe we need to keep ourselves in check, but other than that, like, I think it's imagination that drives us. Like,
It's not anymore.
no, I mean, most of the stuff we're doing, we're looking for like how to use this technology to accelerate cures to cancer, modern drugs, sustainable farming, like to solve problems on our planet, right? That maybe we're not capable of solving individually. So yeah, I think that's what's driving us, is to solve real world problems. And we need assistance to do that. And when we get to the AGI phase, maybe we won't need as much assistance. But I still think we'll still be in the process, right? Because it's to benefit us as humanity and society as a goal. So yeah, imagination is driving us, I think. So good question.
Any more questions? Okay.
It's like, ask Google, they're here.
My question is related to the limitations of computation, and will we be able to push AI further with the current digital or physical limitations, and will be an alternative computing that lives outside the digital world can help to push the limits of AI?
Good. That is a really good question, and maybe that's why I had the topic of like the efficiency and energy and stuff like that. So traditional compute, right? Like I mentioned that Google is developing its own AI chips, TPUs. So we now launch version 6 of our TPU. Maybe I was on stage a couple of years ago talking about version 5. The performance increase from 5 to 6 is 4x. Actually, it's almost 5x. And we're seeing that in generational. Another really good actor in the industry of demonstrating this, maybe more for commercial reasons, is Apple, right? With the Apple's own silicon. They're always like every iteration, M1, M2, M3, M4, you're seeing a multiplier of the compute capacity. Now, obviously, the ultimate thing, and something Google is working on very strongly, is Google has its own quantum chips as well, Willow. And quantum is probably something that will help us accelerate beyond the means of what we understand of compute capacity even to today, right? So will we have AI powered by quantum? Probably, maybe. We're developing quantum technology all the time, right, as a society. So I don't think we have the computational problem or a threshold or a barrier. And I don't believe also we have a data barrier either. Like, we're generating data all the time, and we can create synthetic data. So computation and data boundaries I don't think exist for us at the moment, like, which is kind of unique, right? Like, it's kind of a weird time to live in.
Okay, thank you.
More questions for Google?
One more.
You're up to,
One more? Okay, in the corner, here you go.
Short question. How you would compare Gemma 27 billion to DeepSeek 32 billion?
Depends what I'm evaluating. Like, so the use case is super important, right? Like, when you look at models, the best thing is to say what is the best model for the task. So I don't just promote that, like, hey, Google's model or Gemini is the best model for every single task. Google is actually focusing a lot on coding. So we're trying to position our models and benchmarks to make the best coding models. Ironically, maybe it's due to making lots of cat videos on the internet. We're also really good at generative media, so creating images and creating videos. So Veo, for example, Gemma can do some stuff too. We're the best at that, but maybe it's because we have a lot of training data, aka YouTube and a lot of other stuff, right? Like out there. So yeah, it depends on the use case. And what we find is it's best to use the best. It's like a toolbox, right? Like you can't say this is the model. This happened very early on in AI. Like this is the model. We've picked this one. We've selected, you know, OpenAI. And then you do a task. Oh my God, it's crap at that. And you use Gemma or you use Gemini, and you're like, oh, it's not very good at that. But Claude is really good. Claude is actually really good at reasoning, semantic reasoning. I'm going through and saying, breaking down a problem. A little bit better than even Gemini. Maybe the next model will be better than Claude. It's like a game like this. So it's choosing the best model for the task at hand. And that's why I highlighted that Gemma 27 billion, specifically for cancer, like a variation of it, best model for best task. So you've got a toolbox. Don't just use one tool. Not everything is a nail when you only have one hammer, right? Like, so, great question. So I think I'll get off now. So.
All right. Thank you, Mark, for this insightful talk. Another round of applause from him.